A startling discovery made by the James Webb Space Telescope has seized the attention of the global scientific community. The observatory has identified what seem to be artificial light patterns originating from a cosmic location approximately 7 billion kilometers away from our planet, sparking fresh theories in the continuing exploration for life beyond Earth, while zeroing in on Proxima Centauri b, the nearest known exoplanet to Earth. The telescope registered peculiar luminous phenomena, appearing to radiate directly from the planet's terrain. These inexplicable bright spots on Proxima Centauri b have prompted the question, could this truly be an indication of extraterrestrial activity? For countless generations, humanity has gazed into the night sky, yearning for even the smallest clue, suggesting we're not alone in this immense universe. Any credible suggestion of non-earthly life has always stirred massive intrigue. Recently, the astrophysical world was left astounded when information found on the internet could potentially signal the existence of other life forms somewhere in the cosmos. During its deep space observations and the transmission of invaluable information back to Earth, Webb recorded striking light anomalies, Zerbin-like illuminations emitting from the surface of Proxima Centauri b, an exoplanet residing within a far-off star system. These luminous phenomena are being labeled as the first extraterrestrial artificial lights ever recorded in space, resembling the nighttime glow of a distant, possibly inhabited metropolis. The hypothesis that an advanced species might be flourishing in this remote star system has mystified researchers, immersing them in a wave of awe and speculation. Many scientists are gripped by the extraordinary notion that this could be their revolutionary moment, one they have long envisioned. If validated, this would confirm that intelligent beings have evolved complex societies light years beyond Earth's technological framework. And we are only now catching the first glimpses. As experts examine the light originating from this distant system situated over 7 billion kilometers from Earth, engineers and astronomers alike pondered just how long these radiant patterns might have existed, waiting patiently until our observational tools became advanced enough to perceive them. David Kipping, an astronomer from Columbia University, characterized Proxima Centauri b, the exoplanet where these supposed urban glows were witnessed, as a heavenly object with dynamic thermal properties that starkly diverge from the standard behavior found on other rocky planets. Whereas most terrestrial planets absorb sunlight and then emit heat as infrared radiation, Proxima Centauri b exhibits a far more distinctive interaction with its parent star, Proxima Centauri. This novel planetary response has rendered it an especially intriguing subject for Webb's cutting-edge infrared sensors, which are designed to detect subtle heat signatures with remarkable accuracy. The unique temperature emissions of Proxima Centauri b hold the potential to unlock deeper insights into its atmosphere and, perhaps, its habitability. Scientists leveraging Webb's state-of-the-art infrared observation tools aim to delve into the atmospheric enigmas of this planet, investigating whether the environment may harbor the necessary conditions for biological life. Webb's advanced ability to capture the faintest hints of light makes it a perfect candidate for studying celestial bodies like Proxima Centauri b. Its incredibly focused frequency range, narrower than what most stellar light occupies, enables it to identify potentially artificial light sources, transforming it into an unparalleled asset in the hunt for alien life. The ever-changing interaction of the planet's physical properties and the star its orbits adds another layer of scientific value. On the sunlit side of the planet, large solar energy arrays appear to collect energy directly from the star, while the dark hemisphere experiences incredibly low temperatures. This stark thermal disparity, caused by the planet's specific atmospheric characteristics, presents a fascinating area for researchers to explore. Webb's capabilities extend further, allowing it to measure the thermal emissions from Proxima Centauri b with high precision, yielding critical information about the gases and composition present in its atmosphere. The telescope's trajectory is designed to stay aligned with Proxima Centauri b's orbit, ensuring that both the illuminated and shadowed sides of the planet are thoroughly examined over its 11.2 Earth-day rotational cycle. This synchronization provides scientists with an exceptional opportunity to study the planet's complete daylight system. Moving forward, a critical objective is to perform a chemical breakdown of Proxima Centauri B's atmosphere to evaluate its potential to sustain life. Scientists are particularly interested in detecting key gases oxygen, methane, and water vapor that are typically regarded as biomarkers that could indicate life. Should such molecules be found, it would imply that Proxima Centauri b might possess the vital elements needed to support living organisms. Yet, identifying these indicators from such a remote distance remains extremely difficult. The procedure necessitates capturing and interpreting the starlight as it filters through the planet's atmosphere. Though Webb is proficient in this kind of atmospheric analysis, especially using infrared wavelengths, it still encounters obstacles, especially when attempting to detect molecular oxygen, one of the strongest signals of biological activity. Nonetheless, the observatory is well equipped to search for other related substances, like ozone, which have the potential to provide alternative clues to a planet's habitability. However, one must keep in mind that Webb's observational reach is inherently constrained. It cannot examine every possible life-supporting planet and is limited mostly to analyzing exoplanets located relatively close to our solar system. To expand these investigations, astronomers are increasingly dependent on advanced ground-based telescopes such as the extremely large telescope ELT, anticipated to become operational in 2028. This massive observatory will provide unmatched resolution and allow astronomers to dive deeper into the exploration of planetary environments. Located light years away, the future promises the deployment of even more sophisticated space telescopes, each designed to expand on Webb's past and enhance our ability to detect planetary reflections more accurately. Upcoming missions are focused on minimizing interference from a star's brightness in order to isolate planetary atmospheric reflections more clearly. This development will empower researchers to distinguish between biologically gaseous emissions and natural ones from purely geological activity. Despite the various obstacles, scientific momentum shows no signs of slowing down. And Webb stands at the forefront of this monumental leap in understanding alien worlds and the larger universe that encompasses them. Following numerous years of intensive research and the unwavering pursuit of cosmic life, one fundamental question remains unanswered. Are we the only sentient beings occupying this vast cosmos? Efforts to respond to that question lie at the core of modern astronomy. Each new discovery, regardless of magnitude, adds depth to the mystery and fuels enthusiasm for what lies ahead. The recent detection of enigmatic radiances from Proxima Centauri b, courtesy of the James Webb Space Telescope, has introduced a new layer of excitement into this age-old pursuit. If these lights do, in fact, result from artificial activity, the consequences would be nothing short of revolutionary, challenging established assumptions about our solitude in the universe. Such a revelation would suggest that intelligent, technologically capable civilizations may be far more prevalent throughout the galaxy than once believed. The notion that life could have flourished to advanced levels light years away confronts and redefines our scientific knowledge of the universe, its time, and evolution. Although the investigation is still in its preliminary phases, the discovery of these potential artificial lights on Proxima Centauri b provides a powerful suggestion that we may no longer be alone. Located a mere 4.2 light-years from Earth, Proxima Centauri b stands as one of our most likely future targets in depth exploration. The Webb's ability to detect such faint, deliberate light patterns from a location so distant is a remarkable testament to human advancement in space-based observation technology. As researchers continue to pore over the data supplied by the Webb, They're not only focusing on these enigmatic radiances, but also paying close attention to Proxima B's atmospheric signals that might indicate the presence of life. Temperature patterns across the planet's surface will also be studied thoroughly, as they can yield valuable insight into how the planet retains heat and whether it hosts a suitable environment for organisms. With additional data, researchers will be able to refine existing models, making more accurate predictions and bringing us closer to resolving humanity's most timeless question: are we truly alone? In parallel, major space agencies such as NASA and various international co-workers are speeding up their development of next-generation observational tools. The next era of the ELT and other telescopes will provide astonishing clarity and allow scientists to scrutinize alien planets like never before. These new instruments are expected to significantly enhance our comprehension of distant celestial bodies, such as Proxima b and others that might have the ingredients for life. Well, the Webb has already revolutionized space exploration through its breakthroughs. Its long-term value continues to grow. Its extraordinary capacity for observation promises to facilitate continuous exploration, helping scientists understand not only how planets form and change over time, but also how they might evolve to sustain biological ecosystems. With each advancement, we edge closer to unveiling truths that have mystified humanity since ancient times. Beyond analyzing the curious lights on Proxima b, upcoming missions are expected to gather additional information on the planet's chemical makeup. Special emphasis will be placed on detecting gases frequently linked to living systems: oxygen, methane, and carbon dioxide among them. The presence of these elements in an alien atmosphere would serve as persuasive evidence, indicating the possibility of extraterrestrial biology. However, pinpointing these substances is far from straightforward. One of the biggest difficulties lies in distinguishing the feeble gas signatures from the overwhelming radiance of the planet's parent star. Future telescopes with enhanced spectrographic and imaging capabilities are expected to overcome this limitation, granting researchers the precision necessary for making statements about the chemical environments of planets like Proxima b. These enhancements will be crucial in deciding whether planets of this nature genuinely offer a home for life to emerge and flourish. As the scientific community pushes forward in this pursuit, it remains acutely aware of the restrictions inherent to current tools. Though the James Webb Space Telescope is a technological masterpiece, it cannot conduct a comprehensive survey of every potentially habitable world. Its range is limited to certain types of stars and planetary systems. To close these observational gaps, terrestrial observatories must complement the Webb's findings by providing more adaptable and extended views of the cosmos. The path ahead for astronomical discovery is filled with promise. Armed with powerful tools like the Webb, the ELT, and other high-tech instruments in development, scientists are now poised on the edge of major revelations. Are we nearing a time when proof of intelligent alien civilizations will be unearthed? Or will we ultimately find ourselves alone in the universe, as was previously believed? Continuous observation, improved instruments, and time itself can bring clarity as we push deeper into the cosmic unknown. Each technological milestone propels us closer to comprehending the universe's vast architecture and humanity's place within it. The Webb's recent observation of structured lighting patterns from Proxima Centauri b provides a thrilling peek at what might lie beyond Earth, a promising indication that advanced life could exist elsewhere. The fascination generated by these mysterious illuminations stems not only from their unique characteristics, but also from the staggering implications they carry. Could these glows be signs of a flourishing alien society with progress and development resembling that of human civilization? If future evidence confirms an intelligent origin for these lights, it might mark the dawn of a transformative chapter in our cosmic exploration, although current interpretations remain cautious and grounded in scientific scrutiny. The very fact that such dim light signals are being picked up across interstellar space underscores the monumental capabilities of our spacefaring technology. The Webb's unmatched proficiency in detecting even the slightest light-based anomalies and identifying their origins signifies a significant advancement in our astronomical journey. Looking to the future, scientists are committed to persistently monitoring Proxima Centauri b with every available scientific instrument. One of the next essential objectives includes expanding refined atmospheric scans of the planet, particularly focusing on identifying critical gases such as methane, carbon dioxide, and oxygen. Since these compounds are frequently connected to life-related processes on Earth, their detection elsewhere could strongly support the case for alien biospheres. Research into exoplanet atmospheres is still developing, and it involves incredibly delicate procedures. Isolating a planet's atmospheric light against the overpowering brilliance of its parent star is a daunting challenge. However, as scientific methods improve and equipment grows ever more sophisticated, astronomers hope to uncover even the faintest traces of life, signatures scattered across the stars. The Webb is uniquely equipped for this task thanks to its refined infrared imaging systems. This spectral sensitivity allows it to identify heat and light emissions undetectable by previous generations of telescopes. Such precision enables a clearer view into the molecular makeup of distant atmospheres, dramatically improving the search for life. But for all its strengths, the Webb has its limits. One significant hurdle is its difficulty in detecting oxygen, a critical biosignature. This gas is highly reactive and tends not to remain in a planet's atmosphere unless continually replenished, usually through ongoing biological processes. Whereas the Webb excels in identifying carbon dioxide and water vapor, its resolution may fall short when trying to conclusively measure oxygen. Still, the multifaceted hunt for alien life remains active and adaptable. Other observatories, particularly those based on Earth, will play an instrumental role in validating and supplementing the Webb's data. The ELT and its powerful instruments will soon usher in a new boundary between clarity and depth in observing alien worlds. With the combined might of space-based and ground-based tools, humanity is gradually assembling a more detailed and comprehensive view of the environmental conditions shaping planets like Proxima Centauri b.